Okay, so hello everyone, welcome to the 7 days online training program on Google Earth Engine for remote sensing analysis. So basically today is our fourth number days. I will try to explain all this topic for that. And after completing the 3 hours live training program, then we talk about that problem solving class for 1 hour. Okay, so in the problem solving class, simply you can share your problem with me. Just simply share your screen and then show me your problem. Then we try to discuss about the solution about that. So let's go. Let me share my screen. Okay, can you see my screen? Is it visible? Can you see my screen?
Yes, sir.
Okay,
Yes, sir.
okay, thank you. So now continue. Yeah. So basically today's session I discuss about that how to remove cloud and haze from satellite imagery. So basically when you work with rainy season or you work with some place where almost all time we find out the cloud, so then we find out in the cloud in our satellite imagery. But in Google Earth Engine platform we can easily apply, and further we can easily remove the cloud and haze from our satellite imagery, and then we can easily get very neat and clean satellite imagery. Okay, I also ready to show you that Landsat Sentinel, both of satellite imagery, how we can easily remove the cloud and get the very neat and clean satellite imagery. Then we talk about that DEM data, basically digital elevation model data, how we can easily use in Google Earth Engine and create the different types of topographical mapping such as hillside map, slope map, aspect map, elevation map using NASA SRTM DEM as well as also ASTAR DEM. How we can easily use, we also discuss about that. And another thing is that LST monitoring, basically land surface temperature using Landsat satellite imagery. So previous class I'll discuss about the MODIS satellite imagery, but MODIS have a problem. This problem is that when you are using the MODIS in a small study area, we find out the grid or cell. We don't find out the smooth map because MODIS resolution is not good. MODIS is 1000 meter or 1 kilometer resolution or pixel size. So that's why when you monitor the LST, then we must need to use the Landsat satellite imagery to get the more better result for a small study area, to generate the more better map. Okay, using the Landsat imagery we can easily find out that. Okay, so that's why in this case I also try to show you that how we can easily use the Landsat satellite imagery to monitor the LST. We also discuss about that, and how to calculate average, maximum, minimum NDVI for any specific region. Suppose I have agricultural land. So now this agricultural land, I want to monitor NDVI temporal analysis. Basically when plantation phase, or pick up the growth phase, okay, or harvesting phase. So then we find out a pattern when you identify, make a time series chart for your agriculture monitoring or agriculture crop monitoring. We also use this type of things. I have to discuss about that, and how to monitor the urban heat island, because urban heat island is also defined on the LST, land surface temperature. So that's why in the same time I also discuss about that urban heat island, how we can easily monitor and identify this place is urban heat island, this place is urban heat island. So just we identify this type of place, and also discuss about that urban thermal field variance index. So it's one kind of index. It describe about that impact of urban heat island. Okay, what's the impact, where the high impact of urban heat island we can easily monitor using this index, UTFVI, urban thermal field variance index. When you apply, then we can easily identify where we find out the high impact of urban heat island, where is the low impact, what is the moderate impact. So we can easily make the classification, also make the map. And how to make LST time series chart, we will also discuss about that. So let's go one by one. I will try to explain all of topic. I hope you can easily get it. So first of all, I will try to explain about that LST, how we can easily monitor the LST. And if you simply search on the Google, or you can simply visit the Google Scholar and simply search, we find out a lot of paper related to the LST. Suppose I simply search land surface temperature, Landsat, simply search. So we find out the lot of paper regarding this type of topic, land surface temperature. Okay, just a minute. Let me share again. Okay, so you can easily find out a lot of paper regarding this type of topic. So estimate the land surface temperature in the Delhi study area, online global land surface temperature estimation from the Landsat. So you can see there are a lot of paper already published using the land surface temperature related topic. Okay, if you check, suppose, so we can find out. Okay, so you can see the modeling impact of the land use, land cover pattern, urban thermal field variance characteristics, as well as land surface temperature or urban thermal field variance index. Okay, Dhaka metropolitan area. Okay, so you can easily find out the lot of paper is already published. Not only for that, if you check it, so this is the land surface temperature related paper. So basically they are make the combination land surface temperature and land use, land cover. Okay, so today's we discuss about that land use, land surface temperature. When I talk about that land use, land cover, then you can easily relate it. Okay, and then you can easily publish this type of paper. Okay, related to the land use, land cover, and also land use, land cover, and also LST. Okay, so you can easily find out lot of algorithm. So suppose I want to focus, almost all of algorithm are the similar. Okay, not much difference, but almost all of algorithm is the similar. So if you check it, this type of algorithm, so here you can see basically they are calculate. So this is the main equation about the LST. So basically you can see they are TB mainly brightness temperature. Okay, satellite brightness temperature. Then you can see one, it's a constant value, lambda mainly it's the wavelength of emitted radiance value. and rho, basically this is the constant value 1.438 multiply with 10 inverse 2, and also emissivity we also calculate. Okay, and this is the equation. When you calculate, then we can easily calculate the LST. Okay, not only for that, if you check the other paper, suppose I simply search LST using Landsat, simply search on the Google Landsat 8. So you can easily find out, just simply click on the image, then check. Suppose you can see it's one kind of algorithm. Okay, let me open it from the research kit. Okay, so this is the one another work for using the Landsat 8 satellite data to monitor the LST. So basically in this case, you can see, if you check the flow chart, basically they are used at the band 10, band 5 and band 4. So band 5 and band 4, they are used for NDVI. After the NDVI, they calculate the vegetation proportion or vegetation fraction. After that, calculate the surface emissivity using the brightness temperature, and further there apply the mono window algorithm and then calculate the LST. Okay, so it's a kind of algorithm, and there also compare the data. You can see Moody's LST data and also Landsat data. Just calculate the regression. So so how we can easily calculate the regression, y equal relation. Okay, so you can see they find out the R square value is the 0.723. So this type of things, how we can easily use, I also try to show you that for other class, basically 2 more class inshallah for the air quality monitoring. Okay, this type I also added for linear regression model, how we can easily create and also calculate the y equal to mx plus c, and also calculate the correlation coefficient or R square value. We also discuss about that. So let's go, we try to follow. So if you check this algorithm, first of all you need the Landsat 8 satellite data, and we need the band 10, band 5 and band 4. So let's go try to follow this type of step and then write the code. So let me open my code editor.